Hello, in this video I'm going to discuss derivation 200I. So we'll start by showing the conclusion. We see that it's a biconditional, and that means we want to show both of these let's try that again. Both of these component conditionals. And when we've done that, we'll put them together with CB. Let's pause that so it doesn't interrupt us again. Actually, no, there we go. So that's going to be the general strategy. So to show if P then Q, we'll assume CD. Now, the easiest thing to do here is to not bother to show the consequent. I'll remind you that if you want to show the consequent unless you know that you don't need to. And in this case, I can see that I don't need to, and let's think about why. So we look at premise 1 here. We can see that if we can do modus ponens with premise 1, we'll get not Q. And if we have not Q, we can double negation eliminate and get Q. So if we could get the antecedent of premise 1, we can get to the consequent straightforwardly. Can we get the antecedent? Indeed we can, because what we need to get is P or R, and the introduction rule for the disjunction is and. It says if you have one of the disjuncts of a disjunction, you can infer the entire disjunction. And we have one of the disjuncts of the antecedent, we have P, and that means that we can infer P or R. So this, we want R on the right, and we want R, so there we go. And that's the first conditional. Now, you might have done this the long way around. You would have said show consequent, assume ID, and then you might have said, okay, done this. And if you do this, then things get trickier. You need to realize, again, at this point, you could do the addition again, and now you have an indirect derivation with the negation. Otherwise, you have to figure out some other way to deal with that negation, and that's going to be hard. So this is the best way to do it is this way. The next best way to do it is this, and after that things get tricky. So introduction rules, and note that in both cases the fundamental move is to go from P to P or R, either here or here, and then use that in interaction with what we get, or use it to get something out of the conditional or with what we get from the conditional. Okay, let's look at the second premise. So we look at the consequent, we see that it's P, we look at our premises, and we see that the second premise is a conditional whose consequent is P. So you think, well, if we could get Q and R, we'd be done. And if we look at our premises, we notice that the third premise is R. And we have Q on line 10, and that means that we can put the Q and R together to get P. Having the two conditionals, we can complete our direct derivation. So if you found this difficult, you probably found it difficult in either or both of the conditionals, because you got to this not Q and R or not Q or R. And there are, at that point, a couple of different things. What you need to do is you need to use this negated conjunction, and there are a couple different ways you might do that. One is to infer the conjunction using the introduction rules. The second thing is to do De Morgan, is to use the rule De Morgan's, and then work with that, for in this case, that disjunction. Here, it would have been, you would end up with not P and not R, and you can simplify off the left-hand side, the left P. So what's the lesson here? Number one, look for useful introduction rules if you can. Number two, if you have the De Morgan's rules, it's easier to deal with negated conjunctions and disjunctions, and you enable the De Morgan's rules by proving theorem 65 and 66. And if you have neither of those, then you would need to do here, then you would need to see, oh, I have the negation of something. How do, if I could get the unnegated thing, I can do an indirect derivation. How do I get the unnegated thing? Introduction rules again. So that's the general strategy, or those are different strategies for approaching this problem. Okay, I'm going to do a couple of other derivations from the homework, but I'll be doing those in subsequent videos. So I hope this was helpful. If you have any questions, please let me know. Oops.